Good day and welcome. I'm Mr. Simons. Now we're going to be looking at rectangular prism problems on maximum and minimum area, etc. Right, so they say the sides of a base of a rectangular card box, as you can see there, are 3x and 2x. Respectively, the height is y centimeters. The box is open on top without a lid. So what we mean is the top part there's nothing in the top part. Right? 1.1, if the total exterior surface area of the box is 200 centimeters squared, prove that y equal 20 over x minus 3x over 5. So surface area, we simply assume it's each area. If we had to open this box, that side, that side, that side, all the sides, we want to see what area does it cover on the surface. Then 1.2, express the volume of the box in terms of x. 1.3, determine the value of x if its volume is to be a maximum. Alright, so without further ado, the total exterior surface area of the box is 200 centimeters squared. Prove that y equals 20 over x minus 3 over x over 5. Now they said the box is open on top. So we start first. Area or surface area would be length times breadth, which means this bottom area, but we don't have one on top, plus 2 times length times height. So there's my length times my height. I have one this side and one at the back, therefore I'm multiplying by 2. Then 2 times height times my base. I have a side here and I have that one there, therefore times 2, but the first one is 1 because the top is open. Alright, now the surface area, they say equal 200 cubic centimeters. So in the place of area I put 200. Length is 3x, breadth is 2x. There length 3x, height y. There my height is y and my breadth is 2x. So 3x times 2x, 3 times 2 gives me 6. X times x gives me x squared. There 3x times y gives me 3xy times 2 gives me 6xy. Y times 2x gives me 2xy times 2 gives me 4xy. These two are like terms, meaning they have the same variable xy and xy. So I can add the coefficients. So 6 plus 4 gives me 10xy. So I have 200 equals 6x squared plus 10xy. I have to make y the subject of the formula. Can you see there? So first take 6x squared across, so I have 200 minus 6x squared equal 10xy. Then I'm going to divide by 10x so that y is alone. So I have y, 200 divided by 10x minus 6x squared divided by 10x. 200 divided by 10 gives me 20 over x minus 3 or 2 goes in 6 3 times. 2 goes in 10 5 times. X squared divided by x gives me x. And therefore I have now y equal 20 over x minus 3x over 5. To follow, I hope you understand why I didn't multiply by 2. They said the box is open on top. So there's no area for the top section, right? Let's look at the second question. Alright, now in this problem, they want us to express the volume of the box in terms of x. So for rectangular prism, volume equal length times breadth times height. Length times the breadth times the height. So 3x times 2x times y. But from the previous problem, we know that y equal 20 over x minus 3x over 5. So in the place of y, because they want in terms of x, I can't have y. So that's 20 over x minus 3x over 5. 3 times 2 gives me 6. X times x becomes x squared. Now if I multiply in, 6 times 20 gives me 120 x squared all over x. Positive times negative gives me negative. 6 times 3 gives me 18. X squared times x, x cubed over 5. X squared divided by x simply becomes x, so that's 120 over x minus 18 over 5, x cubed. So there my volume only contains x's, and I've written it in terms of x. So although I have x there, I had to get rid of the y because they want everything in terms of x. So we have my equation. Let's look at the next problem. determine the value of x if the volume is to be a maximum. So once we have the equation, we can test now maximum or minimum. Right, so my equation Vx equal 120x minus 18 over 5x cubed. Because it's maximum, I'm going to have to find first derivative, right? So first derivative, 1 times 120 gives me 120. 1 minus 1 is 0. X to the power 0 then falls away. 3 times 18 over 5. 3 minus 1 gives me x squared. So 18 times 3 gives me 54 over 5. Because it's maximum, the first derivative equals 0. Alright, if I take this across, negative 54 over 5 become positive 54 over 5. X squared equal 120. Right, to get rid of that there, I'm going to multiply by 5 and divide by 54. So 120 times 5 divided by 54 gives me 600 over 54, which simplifies to, if I divide by 600 and 54 divided by 6, 9. So x squared equal 100 over 9. Square root of x squared, square root of 100 is 10, square root of 9 is 3. So x equal 10 over 3 for the volume to be a maximum. Right, if they said maximum volume, then this would have gone back in the original equation to find the value. Right, let's look at the second problem, so we get enough of this. A rectangular box is constructed in such a way that the length of the base is 3 times as long as the width. Right, so the width is x there, so technically my length then would read 3x. Material used to construct the top and the bottom of the box cost 100 Rand per square meter. Material used to construct the sides of the box cost 50 Rand per square meter. Box must have a volume of 9 meter cube. Let the width of the box be x meters. Right, so determine expression for the height of the box in terms of x. Show that the cost to construct the box can be expressed as C equal 1200 over x plus 600x squared. Calculate the width of the box, that's the value of x if the cost to be a minimum. So let's look at the problem. Determine expression for the height of the box in terms of x. Number 1, we need to know that the length is 3 times that of the width, so L equal 3x. The volume given was 9 meter cubed. So because they gave me volume, I'm going to use volume to solve for h. So volume equal length times breadth times height. Volume is 9. Length is 3x, my breadth is x, and my height is h. 3 times 1 is 3, x times x gives me 3x squared, h equal 9. So h equal 9 divided by 3x squared. Right, 9 or 3 goes in 9 3 times, so this simplifies to 3 over x squared equal h. So there we have h in terms of x. Right? I hope you follow. 2.2 show that the cost to construct the box can be expressed as C equal 1200 over x plus 600x squared. So first, because they use cost, I need to know the top and the bottom of the box. That bottom area is 100 Rand per square meter. Side of the box, 50 Rand per square meter. So for cost, or surface area, right, for the top and bottom, it's length times x, but I have bottom and top, therefore times 2. The top and bottom is 100 Rand, so I multiply by 100 Rand. Plus, for the sides, I have 2 times h times x. I have this side and the other side there. So 2 times h plus x plus, then I have my length times the height, meaning this front and the back part, also 2. And the cost of the sides is 50 Rand. So length was 3x. Right, so 2 times 3x times x times 100. My height there, remember I solved h, is 3 over x squared times x plus, there for my length, 3x times my height, which is 3 over x squared times 50. Remember, height we solved in the previous problem was 3 over x squared. So 2 times 3 would give me 6, x times x x squared, but 6 times 100 gives me 600 x squared. 2 times 3 there gives me 6. 6 times 50 would give me 300. Right, and I have x over x squared. 2 times 3 gives me 6. Right, 6 times 3 gives me 18. 18 times 50 gives me 900 x over x squared. If we simplify, I have 300 over x and x squared. So they cancel, or 1 minus 2 still gives me x to the power negative 1, or x1. The x and x squared leaves a x behind. Denominators are the same, so I can add the numerators. 300 plus 900 gives me 1200 over x. Alright. And that there, for us to answer the next question, I might just simplify. If I take x up, it becomes x negative 1. So my cost C equals 600x squared plus 1200 x minus 1. So I assume you remember now, for the top and bottom, I did separate to multiply by 100. I had two parts, top and bottom. And then for the sides, I have the two sides, and the front and back two sides. So therefore 2 times the 50. Right, they caught the learners out to this in exam, so I hope you understand and you follow what I'm explaining. And calculate the width of the box, value of x. The cost is to be a minimum. So C equals 600x squared plus 1200 x to the power negative 1, which you found in the previous problem. So because they use the word minimum, I have to find the first derivative and make it equal to 0. So I differentiate my cost with respect to x. 2 times 600, 1200. 2 minus 1 gives me x to the power 1. Negative 1 times positive 1200 gives me negative 1200. Negative 1 would give me negative 2. Right? That I make equal to 0. 1200x minus, my apologies, if I write x negative 2 as positive, take it to the bottom and it becomes x squared. Right? Take that across, negative 1200 over x squared become positive 1200 over x squared, equal 1200x. Multiply the denominator away, so x squared times x would give me x cubed. And I'm left with 1200 equal 1200 x cubed. 1200 divided by 1200 gives me 1. So 1 equal x cubed. We assume you know cube root of x. Cube root of 1 would give me x equal to 1. So in short, the width of the box therefore is 1 meter. So if you enjoy the lesson, please like, share, subscribe. Right? Wish you nothing but the best. Stay disciplined, consistently practice. You're only bound to get better. God bless. Bye.